Hey John, how's it going? I hope you're feeling a little bit better, and hopefully you can watch these before tomorrow. Alright, so I'm actually on the wrong page right now. Awesome. I don't know why I did that. Okay, so you finished Chapter 9's test yesterday, so if you give that to Abby, you can send it into school for me, and I will grade that for you. I think you got around a 70-something on the log test, which is great considering the fact that you weren't there, which is awesome. I did hand in to Miss Tompkins a couple of your homework assignments and bumped up one grade from, I think it was like a 30 to a 50 or a 60, something like that. I'll have to double check for you. But let's just keep moving. I'm going to try to do 2 hours worth of videos for you, and I know that's probably going to be a pain for you to watch them all, but we really need to get through this material. So if you have any questions, same as before, just text me or email me and let me know what questions you have. Okay, so this is Chapter 10, still on trig stuff. Okay, so what we're going to talk about today is basic and Pythagorean trig identities. So these are called the reciprocal identities, and we learned them yesterday, I think, when I talked to you. So that just means that cosecant theta is 1 over sine theta, secant theta is 1 over cosine theta, and cotangent is 1 over tangent. Okay, so Miss Tompkins had these like up on a poster board in the room just so that it would help kids remember them. If you want to do that, you could like put it on a sheet of paper next to you so that you always had it next to you so you could remember it. Obviously you can't use it during the test, but this is really easy. Like I said before, just if you are getting confused about which one goes with which, just remember that there always has to be a C and an S together. So cosecant goes with sine, and secant goes with cosine. Okay. These are called the quotient identities. Now, we call them quotient identities just because quotient means to divide. So the tangent theta is equal to sine theta over cosine theta, which you already knew. We already talked about this. It's pretty easy. Tangent sine over cosine, or opposite over adjacent if you go back to the triangle, the way that we first figured it out. So because cotangent is the reciprocal, all we did was we flipped that equation upside down. So cotangent theta is cosine theta over sine theta. Okay, so the way that I remember this, obviously tangent is sine over cosine, but if you get confused and you're trying to figure out what cotangent is equal to, I always know that cotangent starts with a C and we start with a C on top. That's how I always remember it. You have a C here and you have a C here. So if that helps you, fantastic. Alright, so far so good. Pretty simple. Now these are what we call the Pythagorean identities. Now you know the Pythagorean theorem, which is a squared plus b squared equals c squared, and that's definitely going to be used here, and I'm going to show you how. Okay, so here is a right triangle. And we know that when we have a right triangle, we can use the Pythagorean theorem, right? So you have up here Pythagorean theorem. You have x squared, which is this side of the triangle, plus y squared, which is this side of the triangle, is equal to 1 squared, but 1 squared is the same thing as 1. So x squared plus y squared is equal to 1. That is simply the Pythagorean theorem, just using the sides that we're given. Okay? So we know, and you know from the test that you just took, that this side length of the triangle x is also known as cosine theta, and that this y can also be called sine theta. And that's exactly why we can label this point cosine comma sine. Now because of that, what we're going to do is take that equation right up here. It's still the Pythagorean theorem, and I'm just going to substitute in cosine for x, so this becomes cosine theta squared plus sine theta squared. Actually, you know what? It's this squared is supposed to go right here. So cosine squared theta plus sine squared theta is equal to 1. Okay, that's my mistake. So this is what we call our first Pythagorean identity. And the reason why it's called a Pythagorean identity is because it comes from the Pythagorean theorem. Okay, so cosine squared theta plus sine squared theta is equal to 1. That's something that you need to memorize. You're going to use it a ton of times. It's not going to go away. All right, so let's see what else. There are two other ways that we can write this equation, obviously. So the way that we're going to use this is you are going to take this equation and kind of plug it into equations to simplify things. So maybe you have this long written out equation. It's like secant plus cosecant, and somewhere in the middle of that equation you have a sine squared theta plus cosine squared theta. You can take that whole section out and just replace it with a 1, and it really makes things a lot simpler. Or on the other side, you might see a sine squared theta somewhere, and you might want to use this equation right here to rewrite that. So how could I solve that equation right there for sine theta, or sine squared theta, so that I could get it all by itself? If I want to get sine squared theta by itself, all I would have to do was subtract cosine squared theta from both sides, which is pretty easy. I mean, we're just treating this like a normal equation. It looks a little bit complicated because you're using trig values, but it's really not that bad. It still follows the same laws of algebra. Okay, so these are gone. So on the left-hand side, we just have sine squared theta, and on the right, we have 1 minus cosine squared theta. Okay, so sine squared theta is equal to 1 minus cosine squared theta. And I know that you're very smart, so you could probably figure out what I'm going to do next. If you see in an equation that the cosine squared theta is all by itself, you could solve this equation yet again for cosine squared theta by subtracting sine squared theta from both sides. So subtract sine squared theta and subtract sine squared theta. So what we're left with is cosine squared theta is equal to 1 minus sine squared theta. Now these two equations that we just figured out together, those are actually going to be used more frequently than the first one, than the top one. Sometimes you might see sine and cosine written together, but most of the time you're going to have to substitute in. Maybe you see in the equation 1 minus cosine squared theta, and you can take this whole thing and just rewrite it as sine. You're going to see examples of when we're writing equations and we only want to have one variable, so maybe there's both sines and cosines in there, and you can use these two equations to rewrite sine in terms of cosine, or rewrite cosine in terms of sine, so that we're left with one kind of variable in the equation. And I know it kind of sounds a little bit weird because you haven't seen an example, but I promise that this stuff is not that hard. You could also derive two other Pythagorean identities from this equation. Okay, so let's just review really quick what we have. We have the reciprocal identities, so that's cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. We have the quotient identities, which is tangent is equal to sine over cosine, cotangent is cosine over sine. We have the first Pythagorean identity, which is cosine squared theta plus sine squared theta is equal to 1. And then we rewrote that equation two different ways. So sine squared theta is equal to cosine squared theta minus 1, and cosine squared theta is equal to sine squared theta minus 1. So we have already 8 different equations that you know, okay, just from those couple minutes, 5 minutes that I've been talking to you. Okay, so 7 minutes. Now I'm going to derive 2 other ones. All of these are important, so if you're taking notes right now, I would be making a list and going through and just keeping note of all of these, okay? Alright, so we can derive 2 other Pythagorean identities from this form. Okay, so what we're going to do... Wow, my computer is really hot. That's not good. Okay. What we're going to do is kind of just manipulate the equation a little bit to get out 2 other forms. So what I'm going to do is I'm going to go through and divide every single one of these terms by sine squared theta. And the reason why I'm allowed to do that is because if I'm dividing one of these terms and I divide all of them, then it's like algebraically allowed. You know what I mean? And the only reason why we were trying to do this is because mathematicians, once they figure out an equation, they like to kind of just move it around and manipulate it to see if there's other helpful ways of using it as well. And it turns out that there are 2 other very helpful uses for this equation. Okay, so let's just go through. Sine squared theta divided by sine squared theta, that just turns into a 1. So we have a 1 right here. That's our first part. Cosine squared theta over sine squared theta. Now that's one of the identities that we already went over. And I'll give you a hint that it's a quotient identity. Okay? And you're not here, so you can't tell me what the answer is. But the one where it has cosine on top, or it has c on top, remember how I told you that that's the cotangent? Cotangent squared theta. And the reason why these are all squared is because I'm dividing cosine squared by sine squared. You get the picture? Don't forget the squared parts. Like if you forget to write the squares in a test, then you're not going to get full credit. And then 1 over sine, that's also another identity that we just learned. 1 over sine is cosecant squared theta. Okay? So that is the second out of 3 Pythagorean identities that we have, and all we did was we manipulated that first easy one. And remember that this whole thing came from the fact that we got this from the Pythagorean theorem. So a squared plus b squared is equal to c squared, or x squared plus y squared is equal to 1, blah blah blah. Okay? So if I just went through and I divided everything through by sine and I got another one, what do you think I could do to figure out another equation? If I divide through by sine the first time, maybe we should divide through by cosine the second time and see what happens. So this time I'm going to divide by cosine squared theta on both sides, or on all of the terms. And we're going to see what happens. Sorry, I keep looking at my phone because I have to stop this at 15 minutes. Otherwise I can't post it to YouTube. Okay, so sine squared theta divided by cosine squared theta, that's a quotient identity, and that is tangent squared theta. And I'd be writing this down if I were you. Plus cosine squared theta divided by cosine squared theta, that is just a 1. And then the last part, 1 over cosine, or the reciprocal identity that goes with cosine, that's secant. Okay, so here are your 3 Pythagorean identities that you need to know, you need to love, you need not to forget. You have to memorize these because they're not on any chart or reference sheet that you're going to be able to use, okay? So make sure you have those down. I think that she just used the screen to do it all over again. Okay, so those are the 3 Pythagorean identities, just written right out for you. And I guess I'll keep going. I think I'm going to stop right here, and I'm going to post this video for you, and then I'll come back because I don't want it to be too long. Okay, so I will be right back.